I study some weird frogs. They have big, bulging eyes, plump, oddly shaped bodies, and they always look like you caught them doing something illegal. They are aptly named monkey tree frogs. But I think the weirdest part about them is that they have a lot of DNA. They have about 4 times as much DNA as humans and an extra set of chromosomes. We know that they got this extra set through the duplication of their ancestors' DNA. What's special about these frogs is that the species whose DNA was duplicated is still around for us to compare with. It's an exciting opportunity to see the influence of this extra DNA on recent evolution when compared to a similar species with half the amount of DNA. This animation shows how average annual temperature has changed in eastern South America, where these frogs live, since the last glacial maximum, around 21,000 years ago. Changes in climate and habitat cause changes in the population sizes of frogs, which lead to changes in their genetic diversity. This diagram represents the impact of a population shrinking, then expanding on genetic diversity. And genetic diversity is a key indicator of how healthy a population is, and a more extreme impact of population size change on genetic diversity, seen in the center, can leave a population more susceptible to genetic diseases and leave less variation for adaptation. I'm interested in knowing if starting out with more DNA, seen on the right, buffers the negative effects of population size changes. To study these frogs, you first need to catch some. Fieldwork can be exciting, like ziplining across a river to reach quality habitat, but it can also be a pain, like getting the car stuck in the middle of the night without AAA to help. With tissue samples in hand, the next step is to sequence their DNA and analyze it. And since I can't actually travel back in time, I can use fancy software to simulate the evolution of these frogs. This allows me to keep track of how their genetic diversity has changed over time and see whether more DNA buffers these frogs' responses to environmental change. Simulations are still being refined, but I've confirmed that the frogs with more DNA indeed have more genetic diversity than the frogs with less DNA. Thank you for listening, and I can't wait to deliver some more exciting results.